Dear students, welcome to new video. This video is about the physical quantity, torque or the moment of force, and it explained, especially in this video, which is the first part of torque or moment of force. So it explained how the torque or the moment of force is produced or acts on the door and the spanner. A spanner is a tool and it is used to open the screws or bolt in any machine. So let's come to the topic, and first let's come up to the definition of torque or the moment of force. So look at this diagram. So this is the definition. What is torque or moment? Torque or moment is a turning effect which is produced by any force in any body or in any object. Now for the explanation, we consider in this first part, we consider the example of door and the spanner. It is a tool which is used to unfold or undo or open the screw or the bolt of any machine. So it is the second example. Let's come back to the first example. It is the figure of the door. It is door. And it is the hinges. Hinges mean the support, and but we call it axis of rotation. And now we suppose that if we apply some force, we push it or pull it. So for explanation, let me explain it with the example of book. So look at this. It is a book. Clear? And now suppose that it is a door and I want to open it. When I want to open it, then I will apply the force and I will pull it outward. So I am pulling it outward, and because I am pulling it outward, so this door is coming out. It is not moving along the x-axis. It is not moving along the y-axis. No straight line motion along the y-axis. Not straight line motion along the x-axis. It is turning from here to here. This turning effect, it is not turning effect. It is a door, example of door. This is hinges. But we cannot see the turning effect. We cannot only imagine the turning effect. So this door will come out, and this is my force that I am applying on this door and pulling it outward. Hence this turning effect which is produced in this body. This turning effect is produced by this pulling force. So this turning effect is called torque of force, torque of this force, or moment of this force. I can also, if I want to shut it or close it, then I will apply the force in the inward direction. That was the outward direction. Force was pulling it or acting on this door in the outward direction, but now I am applying the force in the inward direction. Now, if I am applying the force, this is the force. So if I am applying the force in the inward direction, then the torque is, or the moment is produced in the inward direction, and the door is going to be closed or shut. So this was the example that the turning effect which is produced by any force in any body or any object is called torque of force or the moment of force. Now it is the example of the door. This is the door. This is the axis of rotation. I mean to say, this is the axis of rotation. This is the axis of rotation. Now suppose I am pushing it. The direction of arrow shows that force is inward. So I want to shut this door. So it's mean I am applying the force. The magnitude of this force is 3 Newton. And this dotted line shows that force will act or move or turn the door in this direction, I mean in the inward direction, like that. Clear? This is the line of axis of rotation, this is the line of action of the force. Now when I apply the force in the inward direction, then the door will close and it will turn like that. And hence this turning or this rotation is shown over here. So this is the turning effect of this force. This T is the symbol for torque. This T is the symbol for moment of force. This torque or this moment is produced in this body, in this door, in this object by this force. Hence, this turning effect is called torque of force or the moment of force. Now, this diagram shows that this direction of turning is anti-clockwise. Why it is anti-clockwise? Because if we imagine what is the direction of motion of the hands of clock or the needle of clock, then we can remember that the hands of clock or the needle of clock moves in this direction like that. Once again, let me make it clear. If we imagine the direction of motion of hands of clock or the needle of clock, then we can remember that the hands of clock or the needle of clock move or turn in this direction. It is the clockwise direction. But in this case, the turning or the rotation is opposite or anti-clockwise. So the rotation of the body is anti-clockwise rotation. It means this torque is produced in the anti-clockwise rotation or in the anti-clockwise direction. Now, this distance is very important when we discuss the topic of torque or the moment of force. This distance. And how, let me make it clear. Suppose this is the door and I apply the force on this point. Said then this is the distance. The distance, suppose it is the force and I am pulling it or pushing it. So this is the point of application of force, this one, and this is the line of axis of rotation. So the distance, perpendicular distance. Perpendicular distance means, let me make it clear, this is the distance d or the perpendicular distance from the axis of rotation to the line of action of the force. This is the line of action of the force that cannot be shown so clearly in this diagram. However, this distance is making a 90-degree angle. 90-degree angle. Like this is the line of action of the force and this is the axis of rotation. So this is the distance, perpendicular distance. We have shown it like d. It has two names. Number one, forced arm or the moment arm. This d is called forced arm or the moment arm, and it is the perpendicular distance from the line of action of the force to the axis of rotation. In this example, the magnitude of force is 3 Newton and the perpendicular distance from the axis of rotation to the line of action of the force is 10 centimeter. The axis of rotation is, the direction of rotation is anti-clockwise, the body is moving or turning in the anti-clockwise direction. Then now we are going to find the magnitude or the amount of torque or the amount of moment of force produced by this force. So according to the after a great deal of experiment and after the great deal of calculation, the formula or the expression to calculate the value of torque is a product mean multiply. So the product of force acting on the body and the forced arm or the moment arm. Forced arm or the moment arm. The product of these two quantity gives the magnitude or the value of torque or the value of moment of force. Hence, torque or the moment of force is the product of force applied or force acting, this one, and the perpendicular distance or the forced arm or the moment arm d. That is this expression gives the value of torque or moment. Now put the value of force from the figure. So the magnitude of force is 3 Newton. So hence, what is the value of F? 3 Newton. What is the value of D? Force arm or moment arm? The value of D or the value of force arm or moment arm is 10 centimeter. So we multiply the 3 multiply by 10, we get 30 Newton centimeter. How much is the magnitude of torque? How much is the magnitude of moment? There is 30 Newton centimeter in this example, in this case. Now here, mark one thing. Notice one thing, that in this step, I have written N mean Newton. It is a symbol for force, unit for force, and cm is the centimeter unit of length, or this distance, perpendicular distance. Now here it mark it. This, it is not necessary. It is not necessary to write down Newton and centimeter in this step. We can exclude it. We can neglect it. We can ignore this centimeter and this Newton from this equation, and we can write only 3 and 10. But in the final equation, that is the final answer, the units Newton centimeter must be mentioned. Now, what is the direction of torque, or what is the direction of moment of force? So there are only the two directions for the moment of force and moment of direction of torque. Hence, according to the general rule, the direction of torque is find out using the Fleming's right hand rule, which states that when the rotation of the body is anti-clockwise, T stands for torque or moment, this is the rotation of body, rotation of, in this case, rotation of door. When the rotation of the body is anti-clockwise, if you can look at this figure, so this is the rotation is anti-clockwise. Hold the right hand in this way, and now you can change it into this position. Then the rotation of the door or the rotation of the body is anti-clockwise. When the rotation of the body is anti-clockwise, then the thumb will show the direction of torque or the direction of moment, and in this case we see that the rotation is anti-clockwise. Rotation of the door is anti-clockwise. Then thumb is pointing outward. It means the direction of the torque is outward or out of paper. Note this thing. When the rotation of the body is anti-clockwise, like that, then the direction of the torque is out of paper. This principle will never change. Now let's come back to the example number 2. It is comparatively bit easier like that. Now suppose it is a spinner and I apply like that in the downward direction. I want to turn in the downward direction. This is the force applied. Clear? And here, this is the force applied, and force is measured in Newton, so unit of force like that. Now suppose I want to make it turn it in the downward direction, then I will apply the force in the downward direction. And how much force did I apply? Let's say the force applied, the magnitude of the force applied is 10 Newton. This dotted line is is said to be the line of action of this force, and it shows that this force will pull or produce the effect along this dotted line. And when we apply the force like in this direction, then it turns from here to here. So this is once again the example of turning effect, because it is not moving in the straight line like a linear motion along the x-axis. Not it is moving along the straight line in the y-axis. It is turning. Once again, the same definition applies over here. The turning effect produced by any force, and in this case produced by this force. This turning effect is called torque or moment of force, and in this example, this turning effect is produced by this force, as this turning effect was produced by this force. Similarly, this turning effect is produced by this force, and it shows that the body will turn or rotate in this direction, like that. As this body is moving or turning or rotating in this direction, there is a anti-clockwise rotation. So similarly, this rotation is called, if you can imagine how the needle of the clocks or the hands of the clocks rotate, so you can find it that this rotation is in the similar direction, and this direction is called, or this rotation of this spinner is called clockwise rotation. Now, when the body is moving in the anti-clockwise direction like that, then the thumb shows the direction of torque, and in this case we say that when the rotation is anti-clockwise, then the torque or the moment always shows the out of paper, not really out of paper, but it is a convention or tradition. Then this direction is out, the outer direction is called out of paper. When the rotation of the body is anti-clockwise always, then the direction of the moment or direction of the torque is out of paper. So similarly in this case, when the rotation of the body is clockwise mean, look over here, clockwise. When the rotation of the body is clockwise, then thumb is pointing inward. Inward mean into the paper. Hence we say that when the rotation of the body is clockwise, then the direction of the torque is always into the paper. Now in this, once again, what is D? D is same as over here. We call this D force arm or momentum. It is also called the perpendicular distance. So this D is also the similar meaning or the similar sense. This D is also called the force arm or the momentum, and it is once again also called the perpendicular distance from the line of action. This is the line of action of the force to the, this is the center of the bolt, center of the screw, whatever you call it. So this dotted line passing through the center, and hence the perpendicular distance from the line of action of the force to the center of rotation. This perpendicular distance making the 90-degree angle. This perpendicular distance is called force arm or the momentum. And how to calculate the magnitude of torque or the amount of torque or the quantity of torque? We apply the same approach, same definition, and that is the product of force and the force arm. Product means multiply. When the force applied and the force arm both are multiplied or product is taken, the answer comes out to be the value of torque or the value of moment of force. In this case, there is a clockwise rotation, and this is the torque or the moment which is produced in this spinner. So we apply the same formula over here. Hence, what is the value of F? What is the magnitude of F? 10 Newton is the magnitude of F. Put it over here. You can notice that there is only 10, and unit Newton is not mentioned over here, as I have already explained that Newton and the centimeter are not necessary to write down in the intermediate step. It is necessary in the final step. So 10 Newton, and what is the value of force arm or the momentum? That is 8 centimeter, and hence 80 Newton meter is the magnitude of this torque, this moment, which is produced by this force. And now as far as the direction is concerned, so once again, when the rotation of the body is clockwise, then the direction of the torque is the same as the direction of my thumb, which is pointing inward, and hence we can say that when the direction of the rotation is clockwise, then the direction of the torque is always into the paper. It is the out of the paper, and it is the rotation is clockwise, so the into the paper. Hence, hopefully this video would be helpful to you and your concept will be clear. And in the next video, we will discuss the part 2. It is the part 1. We will discuss the part 2 of this topic, torque or the moment of force. And we will see that how the moment of force or the torque of force acts on the lever or on the straight rods. Thanks for watching it.